So when we break our coordinate plane up into 4 quadrants, we label them counterclockwise, starting up here, 1, 2, 3, 4. Same thing that we do in trig, so same sort of numbering. Now, when we plot points, and this was kind of an arbitrary choice, but it was agreed upon by mathematicians, and so that we all know that we're on the same page, we usually label the X and Y indicating the positive direction. So right here, we call this the origin, and the coordinates of the origin would be 0, 0. So whenever we're talking about coordinates, sorry, my phone's making noise and I don't want it to. So when we list coordinates, the first number tells us how far to move in the X direction, and the second number tells us how far to move in the Y direction. So if I wanted to plot the point -2, 1, that says I start at the origin, I would move 2 to the left and up 1. And I'd end up right there at the point -2, 1. If I wanted to plot 4, 3, that says move 4 in the X direction, so 4 to the right, 1, 2, 3, 4, and up 3, 1, 2, 3. You do not have to use graph paper. I think sometimes it's helpful and sometimes it actually gets in my way. If I'm plotting points, I do really like graph paper, but sometimes when I'm plotting functions, I prefer not to use graph paper because it allows me to just focus on the points of interest for the function and not get caught up on making my graph look super precise. -3, -4, this is saying go 3 to the left and down 4, 1, 2, 3, 4. There's my -3, -4. 3, -5 says 3 to the right, down 5, 1, 2, 3, 4, 5, and 3, -5. -5, 0 says move 5 to the left, 1, 2, 3, 4, 5, but then don't go anywhere in the Y direction. So this ends up being right here. And we refer to this horizontal line as the X-axis. And this vertical line is my Y-axis. One thing that can be a little bit confusing, because for me, at least, it feels just a little bit backwards, is notice that the point -5, 0 ended up on the X-axis, but the thing that was 0 was the Y value. So everywhere on the X-axis, my Y is equal to 0. Similarly, on the Y-axis, all of these points, if I picked an arbitrary point here, like this one, that did not move left or right. So that's an X value of 0 and a Y value of 3. So that would be the point 0, 3. And everywhere on the Y-axis, it's true that X is equal to 0. And those two get folks into trouble because it feels a little bit backwards, right? So just sort of something to work on keeping straight in your head. Plotting points is great, but really what we want to get into is thinking about lines. So a linear equation is one that can be written in this form where the variable X is raised to the first power. So any equation that looks like this would have the shape of a straight line when we plot it. So if we look at this first example, 2x plus 5y equals 10. So this is the equation of a line. It's maybe not in, it's not in the y equals mx plus b form that sometimes we think about as kind of the most friendly form for the equation of a line, but it's still the equation of a line because my y variable is raised to the first power and so is my x variable. When we talk about completing the ordered pairs, this right here is indicating that X is equal to 0. So completing the ordered pair is asking us, what is the Y value when X equals 0? And to do this, I'm going to take that equation of the line and I'm going to plug X equals 0 in and then solve the remaining linear equation for Y. When I plug in X equals 0, this would look like 2 times 0 plus 5Y is equal to 10. Well, 2 times 0 is 0. And if 5Y is equal to 10, that must mean that Y is equal to 10 divided by 5 or 2. This next one, in terms of the ordered pair, this is telling me Y is equal to 1 and asking the question, what is X equal to? So I'm going to do the same thing, but this time, rather than plugging in a value for X, we're plugging in a value for Y, or replacing the Y in the equation with the given Y value. Well, when I do that, my equation is going to become 2X plus 5 times 1 is equal to 10. Or 2X plus 5 is equal to 10, which means 2X is equal to, if I subtract 5 from both sides, I've got 2X is equal to 5. And that means my X value should be 5 divided by 2. And I think my pen is running out of ink, so let me try a different one. This is going to be 5 divided by 2. Last but not least over here, this is telling me that my X is equal to 5 and asking the question, what's Y equal to? So when I replace X with 5 in the equation, I'll have 2 times 5 plus 5Y is equal to 10, which means 10 plus 5Y is equal to 10. When I subtract 10 from both sides, I end up with 5Y is equal to 0. Well, the only way that's true is when Y itself is equal to 0. We can organize this same information, the same type of information, into a nice chart. Sometimes we call this a T table because there's kind of a T here. Sometimes we call it a T table. And the table is asking the same type of thing that we just did. When we look at this, that first row says when X is equal to 0, what's the Y value? Which means we would take the equation we've been given, replace X with 0. So I'd have 3 times 0 minus 2Y is equal to 12, or negative 2Y is equal to 12, which means Y is equal to negative 6. And I'm going to give you just a minute to try to fill out the rest of the table on your own. I'll do it really quick. 3 times negative 2 minus 2Y is equal to 12. So negative 6 minus 2Y is equal to 12. If I add 6 to both sides, I'll have negative 2Y is equal to 18, and Y is going to be negative 9, which seems to be what folks are putting in the chat. Awesome. Now, I said that organizing our thoughts like that in the table, we could also think of each of these answers as an ordered pair, the way that we did on the previous problem. So that bottom line where we got X equals negative 2, Y equals negative 9, we can also write that as the ordered pair negative 2, negative 9. I'm going to pause just for a second because that looks like some kind of answer in interval notation, which is really frustrating and annoying sometimes. We have to figure out from the context of the problem, if we have two numbers separated by a comma written in parentheses, we have to figure out from the context of the question sometimes, whether that's an ordered pair or a coordinate. or whether that's something, some sort of interval on the number line written in interval notation. Just wanted to point that out since we've been talking about things and putting answers in interval notation. This is not an interval notation. This is telling us there's a single point, -2, -9. Keeping an eye on the chat in case that didn't make sense. Moving on to example 3. So the question is asking us which of the following ordered pairs is a solution to y equals 4x plus 1. Well, being a solution to the ordered pair, the ordered pair being a solution to the equation would mean that when we take these values of x equals 0, y equals 1, if we plug them into the equation, both sides of the equation would need to be equal. So let's check. So if I look at the point 0, -1, and I take my equation, I'm going to plug the y value into the left-hand side there, and we want to know, is that equal to what we get when we do 4 times 0 plus 1? Both sides are equal, so we say that it is a solution. And I will give you a couple minutes to check these other pairs to see if you think that they are solutions or not. If I plug these in, that y is going in for, 11 is going in for the y. So I'm going to have 11 is equal to 4 times 3 plus 1. And I think, and I'm going to put a question mark there because I don't know that they're equal, right? We're checking to see if they're equal. Is equal to 12 plus 1. And no, they are not equal. This is not a solution. And how about 2, how about 2, 9? Is that a solution? I appreciate the honesty of the folks saying, maybe I wish I knew. That's why it's an option for you. Okay, let's check this one. So I've got that 2, 9, which means we're going to replace the x with a 2 and replace the y with a 9. I'm going to scoot this over so that my face isn't blocking the screen. When we plug this into test, I'm putting the 9 on the left-hand side because that's where the y is. And then I'll have 4 times 2 plus 1. So 4 times 2 is going to give me an 8. So is 9 equal to 8 plus 1? And the answer is yes. This is a solution. At the equation listed for example 4, there's an invisible exponent of 1 on that x and an invisible exponent of 1 on the y. So I know that it's going to be a line. And if I have a line, then any 2 points that satisfy this equation are going to be enough for me to graph it. So I just have to find 2 points, 2 ordered pairs that are solutions to this equation. For me, the 2 ordered pairs that I would be looking for are what happens when x equals 0 and what happens when y equals 0. And that's just because the numbers are easier to plug in. So if I set x equal to 0, then this equation would become 0 plus y is equal to 3, which means y is 3. That's going to give me the ordered pair 0, 3. And I would come over to my graph and say the x is 0, so I'm not moving left or right, but I do need to go up 3. 1, 2, 3. Then I would find the point that happens when y is equal to 0. And if we set y equal to 0, plugging that into the equation, we have x plus 0 is equal to 3, which means we'd have the ordered pair 3, 0. And if this is telling me go over 3, 1, 2, 3, but don't change up and down. And now I'm getting myself a little straight edge here so that I can make a nice line. There are other ways to graph lines, right? Another one is to think about taking the equation of the line and putting it in that familiar y equals mx plus b form so that we can do exactly what was suggested in the chat just now, which is to think about using the slope to move up and over. So let's take a different approach to this one. First of all, I can tell that it's a line because I've got an invisible exponent of 1 on that y and an invisible exponent of 1 on the x. Once I know that it's a line, right, any 2 points on the line will let me draw it, but we can also rearrange this by subtracting 2 from both sides to say y is equal to 1/2 x minus 2. From this version of the line, this is our slope-intercept form, which means I can read off that the slope is equal to 1/2 and that the y-intercept is -2. One option for graphing this is then to start at the y-intercept of -2 and to use the slope to tell me how to move. So this slope of 1/2 says up 1, 2 to the right. So if I start at this point and I go up 1, 2 to the right, and I keep doing that, up 1, 2 to the right, up 1, 2 to the right, we're going to end up drawing in a line that looks like this. And I think I can get a third graph on here without it getting too messy. So this last one, 2y minus 4x equals 0. Again, I've got an invisible exponent of 1 on the y, an invisible exponent of 1 on the x. So I know that it's a line. We can either plug in points or we can think about finding the slope and the intercept. Does anyone have a preference? Plug in points or find the slope and the intercept? You can type it in the chat if you have a preference. And if you don't, I'll pick for us. Okay, slope form, you got it. So if I get this into slope form, then I'm going to want to add the 4x to both sides. So I end up with 2y is equal to 4x. Now, we can keep the 0 if we want to, right? We can keep this saying 4x plus 0 and then divide everything through by 2. So I would have y is equal to 2x plus, and 0 divided by 2 is still 0. You do not have to put the 0 on there. I'm doing it just so that I can remind myself that this is telling me that the y-intercept is 0 and the slope is 2. When the y-intercept is 0, we say that the line goes through the origin. And remember, the origin here is the point 0, 0. A slope of 2 doesn't have a nice fraction for us to work with, right? It doesn't have a nice fraction, but we kind of have to imagine the fraction in there. That 2 is really a 2 over 1, which is saying move up 2, 1 to the right. So if I start at the origin and I go up 2, 1 to the right, up 2, 1 to the right, and then I connect my dots there, staying up 2, 1 to the right, we're going to end up with something that kind of looks like this. And we can also, there was a request to also do that last one by finding points. Absolutely. We can do any of these by finding points or by using the slope-intercept form. I've got some space over here, so that's where I'm going to do it. So we've got 2y minus 4x is equal to 0. And any points at all are going to be fine. So if I were to do kind of take the same approach as we did on example 4, I like to start by plugging in zeros. But when we plug in x equals 0, then what we get is 2y is equal to 0, which means y is equal to 0. So that gives us our point at the origin of 0, 0. But unfortunately, it doesn't give us like 2 points. So now we have to choose any value of x or y at all, like choose something at random to plug in to get that other point. So I'm going to choose to plug in x equals 1. Again, I'm just kind of trying to keep the numbers pretty simple. So if I plug in x equals 1, I'd have 2y minus 4 times 1 is equal to 0, or 2y minus 4 is 0. If I add 4 to both sides and then divide by 2, I'm going to get y equals 2. So that second point would be 1, 2, which matches up with what's on our graph. That would be 1, 2. So those would be the 2 points that we just found. This kind of gets back to what I was saying at the beginning, where even though it's counterintuitive, or for me it is, and it feels kind of backwards, that the x-axis is where our y values are equal to 0, and the y-axis is where our x values are equal to 0. I want to kind of dig into that a little bit in terms of the graphing horizontal and vertical lines. So when I look at y equals 4, I have only one variable, and the power on it is a 1. So this is going to be the equation of a line. When we're asked to find 2 points, if my equation is y equals 4, that means no matter what the x value is, the y value is always 4. So if I think about points, I could have the point 0, 4, 1, 4, -7, 4, 3, 4, any value at all for x, as long as the y value was equal to 4. And if I think about graphing these points, 0, 4 says don't change the x, but go up 4. This says 2 to the left and up 4. And if we can plug in any value for x that we want, and the y value is always 4, this results in a line that looks like this. And this is a horizontal line. Like if you're looking out on the horizon, it Okay, depending on where you are, but let's say you're near a beach. When you look out at the horizon looks flat. In most of the Central Valley, the horizon looks flat. If you have mountains around somewhere, maybe your horizon looks less flat. So if I take a look at this next one, and we've got, sorry, I've got different windows popping up and annoying me. There we go. So if I take a look at that next one where x equals -3, same kind of thing. If this says my invisible exponent on the x is a 1, so I know it's a line. And if I need to find 2 points, that says x is going to be -3, but y can be absolutely anything at all. So maybe I've got -3, 4. Maybe I've got -3, 10 as 2 possible points. So if I'm plotting those, that x equals -3 says 3 to the left. That says up 4. Okay, 10 is like way off my graph. It's, I don't know, up here somewhere. So let me pick something that would actually be on my grid. How do I turn the 10 into something fun? How about the 10 becomes a 0? There we go. -3, 0. There's another point. So when I sketch x equals -3, this is a vertical line. And x equals 0 is secretly the equation of the y-axis. X equals 0 is our y-axis. And if we're finding 2 points that says x has to be 0, but y can be anything at all, like 2, or y could be, how about -4? So if I plotted those points, I've got 0, so I'm not moving in the x direction, but up 2. And 0, 4 says move down 4. So I end up with something that looks like this, and that's my x equals 0. Kind of summarizing those things, that means that my vertical lines will always have an equation with the form x equals a number. And my horizontal lines will always have the form y equals a number. I would say this is not the standard form that most people think of when they think about the equation of a line. I would say the y equals mx+b form is usually the way most of the time people are thinking about it. So we are going to plot a few additional lines, but this time I'm going to show you how I would plot lines if I didn't have graph paper to work with, because I think that this is also a good skill to have. And our first line that we're going to plot looks like y equals 2/3 of x minus 2. Now, I actually think if we're plotting this without graph paper, I think it's easier. So when I look at this equation, first of all, I know it's a line because the invisible exponents on both x and y are 1. Now that I know it's a line, I can look at this and recognize that it's in this y equals mx+b form. So the coefficient on x is my slope. So my slope is equal to 2/3. And the value hanging off the back here of -2 is telling me that the y-intercept is -2. And if I think about that as an ordered pair, That's the ordered pair 0, comma, -2. Well, if I don't have graph paper and I plot this, the thing that's important to note on the graph is a y-intercept of -2 means it should be somewhere down here below the x-axis. And I'm just going to label that as 0, comma, -2. And then for my slope, I really just have to know whether my slope worked out to be positive or negative, and then what it is kind of in relation to a slope of 1. And I mention the slope of 1 because oftentimes when we're graphing in calculus, it's going to be important to be able to recognize whether something is at that perfect 45-degree angle, which is what happens when you're at a slope of 1, or is it less than 1 or greater than 1, like more steep than a slope of 1 or less steep than a slope of 1. So if I come over here to the 2/3, it's positive. So positive means that as I move from left to right, it's going up. 2/3 is less than 1. So that means that as it's going up, it's a more shallow angle. I don't know why we call it shallow. I don't know. It's a more shallow angle than a 45-degree angle. Now, if I wanted to label another point on my graph, I would probably choose to label the x-intercept. Again, because I like to choose to plug in 0 whenever I can. Well, I know that on my x-intercept, the y value is going to be 0. So if I plug in 0 for y, I'd have 0 is equal to 2/3 x minus 2. I can add 2 to both sides. 2 is equal to 2/3 x. If you're me, you'd multiply both sides by 3 because you don't want fractions. And now I've got 6 is equal to 2x, which means that x value must be 3. And there's my graph. There's a question in the chat kind of linking this idea of a y-intercept to what's happening when you're graphing trig functions. And absolutely, that y-intercept is telling us what our vertical shift on the line is. In this case, it's shifted down 2. And we're talking about, with the y-intercept, we're talking about how it's shifted relative to 0. Good times? Let's grab another one. I'm going to erase things. Well, on this next one, the 3x plus y is equal to 3. I do the quick check to see my powers on x and y are both equal to 1, which means we are graphing a line. But this one currently is in standard form. If we want to use the slope and the intercept to be able to graph this, we first have to rearrange it to put it into our slope-intercept form. And I guess I can label this guy slope. In this case, the only thing I need to do is subtract the 3x on both sides to get y is equal to -3x plus 3. So I've got that slope right here of -3. and my y-intercept of +3. And when I go to graph it, I'm going to start with my y-intercept of +3, which means it's somewhere up here above the axis. And then a slope of -3. A negative slope means that as I move from left to right, I'm coming down. As I move from left to right, I'm coming down. And a slope of -3, if that's about a slope of 1 or a 45-degree angle, a slope of -3 is going to be more steep. It's going down, like if you imagine that this were a slide, if I've got my slide with a slope of -1 and that slide with a slope of -3, you're going down a lot faster. If we want it, and we can label points here. So that one we already know, the y-intercept, the x value is always going to be 0. And we had that y-intercept of 3. To get the x-intercept, when it's in this form, we have to do a little bit more work because we're going to plug in 0 for y. We kind of end up undoing what we just did. I'm going to add the 3x to both sides and get that x is equal to 1. And in general, when we're graphing lines or parabolas or cubics or your fun trig functions, in general, if we're graphing a line, we should always label 2 points. And a lot of times the 2 points that you might be specifically asked to find would be the x and y intercepts. But in general, when you graph a line, we always want to label 2 points. Gonna erase it, get one more on here. I've got -2y minus 5y is equal to 10. You can absolutely find 2 points, plot 2 points, get our graph going. But if I want to put this into slope-intercept form, oh, one of those should be an x. They aren't both y's. I'm assuming the first one. Yep. Okay. If I want to get this into our kind of y equals mx+ b slope-intercept form, I'm going to start by moving my x's to the right-hand side. So I'm going to add 2x to both sides, which would give me -5y is equal to 2x plus 10. Now I'm going to divide both sides by that -5. And when we divide by -5, it's okay to leave it as one big fraction, but in that one big fraction, it's not quite in our slope-intercept form. So we're going to want to be careful. We are not going to take the 10 and -5 and cancel them out. We can only cancel something from the top and the bottom if we can factor it from both parts. Instead, we're going to have to take this piece and rewrite it as 2 separate fractions. We're going to have to rewrite that as 2x divided by -5 plus 10 divided by -5. This is going to look like -2/5 x. And then 10 divided by -5, I'm going to go ahead and simplify that to say -2. Now I can see that my y-intercept is -2 and my slope is -2/5. Now I just want to pause for a second because if we go back up to the original equation, we can look at the coefficients on X and Y to kind of see what the final slope will be. For me, that would just be memorizing another formula that's not worth it because it just takes 30 seconds to a minute to rearrange this, and then you don't have to memorize another thing. But if you wanted to memorize a thing when this is in the standard form, we look at our coefficients on X and Y, and our slope is negative A over B. I don't recommend bothering to memorize that. I'm just pointing it out because it's an option. And if we think about it for this equation, if I were doing that, our A was equal to -2, B was equal to -5. So if we found our slope, we would have the negative of -2 divided by -5, which gives us the -2/5 that we knew it should be. Now let's get to graphing. I'm shifted down 2, so I know that I should be somewhere down here for that y-intercept. My slope is negative, so I know that as I move from left to right, I have to be going down. And then that's a slope of 1. 2/5 is less than 1, which means my slope will be more shallow than that. And it's shifted down here. So something that looks like that. Here, we already found that intercept was 0, -2. And if I needed to find the x-intercept, that's coming from setting y equal to 0. This time I'm going to cheat and plug my y equals 0 into the original equation. Sometimes this is called the cover-up method. If I plug 0 in for y, I can just cover up that term and then see what x would have to be equal to. So if -2x is equal to 10, x would need to be -5.